highlight video of a user-specified length using most replayed data. And this work was done in collaboration with Professor Junyong. Highlights is a short edit of the original video that includes the most engaging and important moments. And these highlights are often utilized in TV broadcast as footage of summarizing a specific event, and they are also easily found in many social media platforms. Since this platform favors a brief format, highlights are often produced as short-form contents with a concise runtime. Regarding their practical use, highlights often need to be created to fit a specific length. In the case of TV broadcasts, they must be produced to fit to allotted time slot and adhere to strict advertising or program schedules. When they are posted to social media, each platform has its own maximum video length limit for nodes, and the preferred content duration varies across platforms. Therefore, to align with platform-specific characteristics and guidelines, highlights should consider this time constraint when being created. Although there are a lot of automated methods for generating highlights or summarized video in the field of computer vision and computer graphics, all prior methods generated highlights of arbitrary lengths. Because they focus only on how effectively to summarize the video, thus they did not control the length of the final output highlight lengths. Therefore, even with input original video of the same length, their methodology could produce highlights of different lengths depending on the contents, and the lengths neither predictable nor controllable. So, in response to this problem, our goal is to develop a system for auto-generating highlights of a user-specified length for the first time. If a user wants a 30-second highlight, our system generates 30-second highlight. Or if a user wants a 60-second highlight, then our system generates 60-second highlights. It also works for any other specified lengths like 100 seconds, 3 minutes, 5 minutes, etc. So to achieve it, we need a process that involves finding engaging moment in the video for effective summarization and optimizing internal segment durations to fit to a specified length. Now I will talk about our research concept. First, to gauge engaging moments in the original video, we use most replayed data called MLD. The white curve places above the video play bar in the YouTube interface. The curve indicates how frequently video has been watched over time, and its data is accessible to everyone. In our investigation, it actually aligns very well with important events in the video, such as goals and soccer matches. MLD also showed a high correlation with other known engaging factors, such as in-video sound and lecture frequencies. We also analyzed quantitatively and qualitatively how well MLD aligns with engaging movement across diverse video genres. For detail, please see our supplementary paper. And so back to our research concept, we gauged the user engaged movement via MLD. And then to generate highlight to fit a user-specified length, we optimize internal segment durations. As you can see, increasing the user-specified length allows more key moments to be included, and the length of each segment may also vary to meet the desired length. Now I will hand my mic over to Minsun. She will explain how our method was developed.
Our method is straightforward and intuitive. First, we obtain the MRD graph from the YouTube video player interface. It is sampled at 1-second intervals, and we select timestamps matching their user-specified highlight length and user. For instance, if the user-specified length is 8 seconds, we select 8 timestamps. Each selected timestamp is assigned a reward according to the reward function, which considers two factors, MRD and R duration. First, high MRD values yield high MRD viewers. For example, selecting timestamps from high MRD areas yields a high total viewers, whereas selecting from the low MRD areas will yield a low total reward. Second, the duration reward will be high when the segment has a decade duration. This reward is implemented through the equation that takes the segment duration d. This is designed to gradually increase the reward for segments with decade durations based on cinematographic principles and decrease reward for segments that are excessively short. In the case of this red excessively short segment, when its length d prime is applied in the equation, duration reward becomes a negative value, ultimately penalizing the total reward. This prevents jarring transition and allows viewers sufficient time to grasp the content. Ultimately, there can be hundreds or even thousands of different segment combinations, varying both in the number, composition, and duration of the segments. Segments with high MRD values and appropriate duration will yield a high total sum of reward, and our method employs dynamic programming to select the optimal highlights. Now let's see the results of their method. As you can see here, as the user-specified length increases, more segments are included. 3 segments for 30 seconds, 4 segments for 60 seconds, and 7 segments for 90 seconds. Simultaneously, each segment duration is optimized accordingly to fit the user-specified length. Here are additional results from various video genres, including audition, sports, and music concerts with different user-specified lengths. For more details about the method and additional video results, please refer to our paper and project page. Our method also allows user-driven highlights customization, enabling users to specify timestamps to include or exclude from the highlights. This customization is achieved by increasing or decreasing the MRD values at selected timestamps. In the case when the user selects this timestamp, the MRD reverse is rated higher around here, resulting in segment containing this being included in the final highlights. Here is an example of customization. The highlight on the left is generated by selecting timestamps of player A 10-point shots, while the highlight on the right is generated by player B 10-point shots. We conducted 2 comprehensive user studies to demonstrate the effectiveness of our method. In the first study, our object is to evaluate method for generating highlights over user-specified lengths under the same MRD. Therefore, we compare our length optimization method with that of previous method, which is gesture-based method, selecting frames from high MRD to low MRD until user-specified length was reached, and the random selection method, which randomly chooses segment without considering MRD but matching the user-specified length. Participants rated each segment regarding segment duration appropriateness, key moment inclusion, and overall satisfaction. Results show that highlights generated by our method received significantly higher scores compared to the previous methods. In the second user study, participants compare highlights generated by our method against human-edited highlights, all edited from the same original footage. For human-edited highlights, we use those already uploaded on YouTube. We set the user-specified length of our method to match that of the human-edited highlights. After watching these 2 versions, participants were asked to select their preference among 3 options: our method, the human-edited, or the curved preference. The analysis reveals no statistically significant differences between ours and human-edited highlights, indicating our method can successfully produce highlights comparable in quality to those created by human editors. Our method can be applied to all videos even when MRD is unavailable. For example, videos not uploaded to YouTube or those with low view counts. In these cases, our method employs a deep learning model which can predict MRD graphs from any input video. This is 30-second highlights using our method based on the predicted MRD. This shows that predicted MRD also successfully captures engaging key moments such as goals in the final highlights. Furthermore, our method also universally applicable to any type of engagement data beyond MRD. Whenever a video is paired with any engagement graph, such as live chatting speed for streaming, TV viewership ratings, or in-video sound loudness, and other engagement data, our method can generate highlights. Our method can be extended for more advanced highlight generation, such as adapting to various aspect ratios through automatic region of interest detection, creating subject-specific highlights using person identification, or generating narrative-based highlights using video description models. Our contribution can be summarized as follows. First, we explore the implication of MRD and propose its first application system. Second, we propose the task of generating highlight with user-specified lengths for the first time. Finally, we developed the novel highlight auto-generation system optimized for user-specified lengths. For more details and results, please refer to our paper and project page.